Hi, Data Ben here. Today we're going to cover interfaces, classes and objects in VBA and how to implement them. Let's get started. First we need to add class modules to the VBA code. These are different to the Microsoft Excel objects here, which are the worksheets, and the standard modules where you usually write VBA code. So to do this, you click Insert and then Class Module. In this example, we're going to create a pet shelter where we're going to be able to add animals, in this case cats and dogs, as objects in VBA, be able to add attributes to the animals and then be able to print out these attributes into the immediate window in VBA. So what we're going to have here is animal as the interface, which we'll cover first, and then cat and dog as individual classes that we'll be able to instantiate later on. Let's have a look at animal first. So the animal module is an interface, and an interface is simply a way to require the classes that are generated from this interface to instantiate these methods, to require these methods within the classes. So what we're saying here is that each animal should have a name, an age, a weight, and it should be able to talk. In this case we mean saying a meow for a cat and a bark for a dog. So we're saying that these properties are relevant to all animals, whether it's a cat or a dog. And what's going to happen is that the cat and dog classes are going to implement this class, which is going to require that these properties are needed. So let's define interfaces and classes. So if you think of the animal interface or any interface in VBA as a schematic, so it's a plan, you've rolled out a plan onto your desk and you've got the plan of animal, and you may draw the most basic animal you can think of. It has 4 legs, it may have a name, it has an age, a weight, and so it has these basic properties that all animals have, and this is a basic schematic of an animal, and this would be the interface, what other classes implement. So what's a class? So below that schematic of animal, if you imagine 2 more schematics of a cat and a dog underneath, and they've just got a few more details, they're a bit more defined. So the cat is also an animal, but it has whiskers, it has a tail, it meows, and it has fur, and it has these properties that make it obviously a cat schematic, a cat plan, or a cat drawing, so to speak. And then the same with the dog. So the dog also has a tail, 4 legs, fur, but it also has a bark and larger teeth and things that make it bigger ears and things that make it a dog. So you can look at those 2 schematics below the animal schematic that derive from the animal interface as 2 different classes. So a class essentially is a plan for an object. So at this moment in time, we don't have any cats or dogs. We just have the plans for them. So we have the animal interface plan, schematic, and below that we have the cat and dog classes, which are also schematics. So the next thing we want to do is we actually, from those schematics, from those classes, those cat and dog classes, we actually want to create new objects based on them. So the actual cat and the actual dog. So if you imagine this, when we create a new cat, we create a cat from the cat schematic, from the cat class, and that cat is then a real cat that we can interact with. We can give it 4 legs, we can change its parameters. So if you imagine an actual cat jumping out of the plan, jumping out of the schematic, and you've created 1 cat, and then another cat out of the schematic, you've created 2 cats. So it's a good way to think about it that each time you create a new object, you're creating a new object from a class. You're creating a new cat from a cat class. You're creating a new dog, which leaps out of the dog schematic and becomes a real dog with a name, out of the dog class. So that's a good way to think of it. So in summary, you've got the animal interface, which all animals have properties of, and the cat and dog schematics, which are classes, so the cat and dog class, and then the real cats and the real dogs that you create from those classes. Okay, so we have the basic interface of what an animal is, which is a name, an age, it has a weight, and it can talk in some way, whether with a meow or a bark. Let's now go down to the next level of looking at the cat class, the first of the two classes we have here. So the first thing you'll see is that the cat class implements the animal. So it implements the animal interface, which means it's going to require those minimum parameters, those minimum properties of name, age, weight and talk. But because it's a cat class, it can also implement its own additional parameters and properties as well. So for example, the cat has a collection of likes, so things it likes such as eating and playing and so on. And it also has a meow, which is a separate to the talk, in that we've actually created a meow parameter here. So we can actually ask the cat, ask a cat object that's created from this class. We can actually call it to meow, which we'll show later on. So this implements the animal interface and adds a couple of new properties of its own. Okay, so when we first initialize a new cat object, this will automatically be called. So this class underscore initialize is a keyword in VBA. It's not, you can't call this randomly class init or anything like that. This specific word is reserved for the creation of a class. The same with class terminate. So when a new object or new cat object is created, this is one, and when the cat object is destroyed, this is one. And the useful thing you can do is when the class is initialized or constructed, you can set some initial parameters. So what we're actually doing here is saying we're assuming that the new cat has 4 legs and its meow looks like this with the meow here. And also when the cat object is deleted, it will print out this line here just saying that the cat class instance is deleted, goodbye. So these two aren't actually required, they're assumed in the background. So they are run each time, but for example, if we didn't want anything special to happen when the class was terminated, so it was just blank, you don't even need to put class terminate at all, so you could delete the entire method there. Same with class initialize. If there were no default construction requirements, then you could delete this entire class initialize method here. So you could delete that and the code would still run. It would just assume that these two are being run. So essentially they would run like this with no code in them. But instead of just cluttering up your code, you can delete these sections entirely if you don't need them. Okay, you can see that we've declared each parameter in the cat class as well. So we've actually declared them with an underscore underneath. This indicates that they are member variables within the class, so that they are private variables self-contained within the cat class. So if we scroll down here, we can see what we've implemented something called getters and setters for each of these parameters. So for example here, if we start with we have get legs, and this means we are able to call the number of legs that the cat has. Then we have get name, so we can call the cat's name. And here we have the first setter, which is defined as let. So there's two ways to set parameters in VBA classes, and this is with the let or set command. Let is for simple data types such as strings and integers, and set is for objects such as collections. So you'll see let is the one that's most used. So we see here that we take a value and then we set the local private parameter as name, and then same again, we get the age, set the age or let the age, we get the weight and let the weight, and then next we have a list of likes that are stored in a collection. So a collection is just a list of items. And you'll see here we have get likes, and we use the set keyword here when we're setting the local likes variable. Also when we're returning the likes variable. And then we have the set instead of let here because it's a collection, and this sets the local likes to the value that we've passed in, or the list that we've passed in. And then we've got the talk where we output the meow for the cat, and then we've actually got a separate one called meow which outputs a string and then with a meow, just to show that this is the cat class specifically. It's just something unique to the cat class, and that we'll talk about a little bit later. And then finally we have the required interface properties. So because we implemented at the very top line, we implemented implements animal, we have to therefore implement each one that is in the interface, or each parameter that's in the interface. So we need to implement the name, the age, the weight, and the talk. And we do that here by doing the animal underscore. So you have to have the name of the interface before the parameter here. So we have animal age, animal weight, animal talk. So if this wasn't called animal, if it was called something else, we would have to rename these to what the interface was called. And this is so that we don't get any errors, and that we actually get the pop-up IntelliSense to work, which will show when we're calling the cat class, which we're going to do next. So we've defined the cat class here, but you may not understand why we're getting and setting these properties like this. And the best way to show how this works is to actually create a cat from the class, from the schematic, and then assign these parameters and variables to the individual properties here, and then get them in return. Let's look at that next. Okay, so far you may just have the animal interface and the cat class, but with nothing actually created. So let's create a main module, which is a standard class. So just insert module, and I've just called it main, and we're going to create a cat. So let's create a new cat object based on the cat class, and the cat class inherits the animal interface. So let's do this line by line. Okay, so if you press F8 or Command-Shift-I on Mac, it will start running the code line by line. So let's start here with the dim cat as new cat. So what we do here is we've said we're declaring a cat object. This could be called anything, but we've actually called it the same name as the class. This usually works okay, but you could, if you want to differentiate the name of the cat to the cat class, you can do that as well. So we've created a new cat, and now we're actually going to set the name. So if we run through this by line, we've gone cat.name equals Missy. And actually, if you begin to type cat dot, you'll get the IntelliSense pop-up for each of the methods that we've created. And this is a very powerful way to actually look at what properties you can assign to the class that you've created. So we've now created, if you imagine the cat schematic, we've created a new undefined cat, a very simple cat. It doesn't have a name. It's based on the cat class, and all you know is that it's a cat, but we've not given it any details yet. So in my mind, I'm imagining a white fluffy cat with no name and no discernible details whatsoever on it, but it's jumped up and out of this schematic, out of the class. It's an object we can pick up and look at and assign things to. So we have this cat, and we're going to call it Missy in this case. So if I Control-Shift-I, you'll see it's gone, instead of going to the name setter, it's gone first and just once to the class initialize, because this is the first time the class has been called. So first of all, we have this cat, and we've gone, okay, pop, it's now got 4 legs into existence. Even when we took the cat from the class itself, it didn't even have any legs. So now it suddenly has legs, and now it has a meow. So we've initialized the class, this new cat object with some default parameters. And then it's jumped to the next section, which is giving the cat the name. So let name, and we give the name underscore private, which is the private variable, the private parameter even. We've given it the value we've passed in, which is Missy. So we've now got a cat that's called Missy. Next, we're giving the cat age as 9, and you'll see there it doesn't do class initialize anymore. It only does class initialize once at the creation of each new object. So then it's going to let the age, and then it's going to let the weight. So it's good to follow this through line by line. And next thing, we're going to actually add likes. So we'll see here at the very top we've declared animal likes as a new collection. So a collection is just a list of items, and you create items using the dot add on the collection. So we're saying that the cat likes food, cat treats and milk. So let's add that, add food, cat treats and milk. But we've not actually passed through this collection of 3 through to the cat object yet. So let's do that now, and this is how we do it. So you do set cat.likes equal to animal likes. So you'll see there we've passed through with the set instead of let now, because it's a collection, and we've passed through the collection of likes here, and we say set likes equal to the value, which is the list, those 3 items, and that's now set as well. So we've created a cat. Let's test the results of the cat that we've created. First of all, we've got a method called cat.talk, so which outputs the meow. So if we debug.print cat.talk, which prints to the immediate window, we'll see it goes to the get talk, and it says talk is equal to the meow for a cat. So, and it outputs the meow. So this cat, we have just asked it to meow, and it's done that. We can also change the meow as well. So we're saying cat.talk equals meow, and now it's going to set or let the talk, and you'll see it's brought in the new meow. A very loud cat this time is meowing in capitals. And then we're going to debug.print the talk again, and this time it's going to output the louder meow that we've just set. And this demonstrates why we use getters and setters. So it's very important that the classes are encapsulated, which means that they're self-contained and that we can have quite limited access to them. So all we want to be able to do as users of the cat class is we don't really want to change the schematics. We don't really, once we've set that up, we don't want to mess around with the insides of that. It's especially if we do some complicated calculations within that schematic. We really want to leave that alone. All we want to do as an outsider creating a new cat object is we want it to be as simple as possible, and we want to be able to set or announce what the parameters we want the cat to be, and we want to be able to change them. So let's say we set the meow like we did there, and we went, nope, that meow is not good enough. Let's alter it and change it to a new one. Then we want to be able to do that without even having to understand how that has changed under the hood. So we have an encapsulated class with access that we allow to the outside world or to the outside programmers. So for example, another example is you don't need to know the inner workings of a spreadsheet worksheet. You don't need to know exactly how the lines are drawn on the screen, or how the cells are automatically coloured white in the background, or how the height of the cells is a certain way when you first open a worksheet. It just is, and those parameters are hidden from you, which is a good thing, because otherwise you'd be overwhelmed with way too much information. So that's what the first reason that classes have getters and setters, is that it keeps the class encapsulated, which is excellent programming practice, and as long as you adhere to it, makes programming in an object-oriented way very simple for you and very simple for other programmers the more you progress with it. The second reason is that you can actually use the equal sign here. So I don't use cat dot apply name equals to, and so on, as have to know the name of the function for it and so on. We can actually treat these getters and setters as parameters. So yeah, there's no apply set name and etc. There's just the name, and there's the returning of the name, or the output of the name, which we'll see next when we actually output these details. So you're able to set and get these in a very simple way, as if they're parameters, as if they're just A, B or C parameters, or any simple parameter in VBA. So you don't want to have to know what the functions are called inside of those classes. Before we print out all of the details of a cat into the immediate window, we actually want to create a new object next, which is going to be a dog, which is only slightly different to a cat, but enough in that we want to give it a new object, a new schematic derived from the animal interface. So if we imagine in our minds moving to the dog schematic now, let's have a look at that class in more detail as well, and then we're going to add the same or very similar parameters to the dog. Apart from the fact it's going to have a bark instead of a meow, we'll be able to add, of course, different likes as well, and then we'll add these specific parameters to a dog object. We'll create a new dog object, and then finally we'll actually output both the dog and cat objects together and see the results of that when we loop through. So let's have a look at the dog class first and just point out any differences that we have. So if we go back into the main module here, and we scroll down to where we're creating the dog. So we've created the cat, and we scroll down and we can see we're creating the dog in almost exactly the same way. So we declare dog as new dog. Again, this keyword here could be anything. And we set up the name, the age, the weight, and then we add 3 likes for the dog as well, which is running in the park, playing fetch, and barking at other dogs. Finally, we set these likes, which is a collection of likes, to the dog likes. We're actually using the same collection that we used for the cat, and we just reset it as a new collection before we add in the dogs here as well. So I'm going to run the code so it fully adds this section all the way through, which happens. So we've now actually created both the dog and cat class, the dog and cat object from the respective classes. And the next thing we want to do is we want to be able to add them to a collection and loop through and output all of the data that we've created for the cat object and the dog object. So we create a new collection of animals, so declare animals as new collection, and we're going to loop through these animals using the animal keyword here, and we're going to actually declare it as a variant, and we'll see why that's helpful shortly. So first we're adding the cat and then the dog, so we're going line by line here, so F8 or Command Shift and I, and then we're going to do on error resume next, because what we're going to do is loop through for each animal in animals. So there's two animals in this collection. We're going to output the details to the immediate window, but they have slightly different methods. So the cat has meow and the dog has bark, but we want to be able to say both without it crashing. So we're actually going to do an on error resume next, and what that does when you type that command is it skips over any errors while the code is running until you hit the line on error go to 0, which basically says, okay, on error resume next, I don't want to see any errors, on error go to 0, you can show all errors again. This is because we're actually using this variant, this animal variant, to change dynamically at runtime to become either a cat object or the dog object, and we can do this dynamically as we go. So first it's going to start with the cat object, and we're going to print the type of object it is. So this type name is a keyword which outputs the type of animal we have. So it will tell us the class, then the animal name, the age, the weight, how many legs it has, and we're going to make it talk as well and output something. So it will go through line by line, getting each of these properties. So get weight, get legs, get talk, so from the cat class, and you'll see there it's output all of them. So it's a cat, name is Missy, the animal's age is 9, and weight is 2.5 kilos, 4 legs, and meow in capitals is the default talk. And we're actually going to ask it to meow if it can, otherwise it will be ignored. And of course this is as a cat, it will meow once more, and it says the cat says meow. So it has actually output this. And then it will ask us, then we will do animal.bark, which it doesn't have, so it will ignore that line. So it's a form of polymorphism there, that we've actually adapted this variant, this animal variant, and it's decided at runtime, at the start of this loop, what type of object that we're looking at. And it's cat. On this first loop it's cat, and the second loop it will be dog. Finally, we want to output the likes. So we're going to say for each pet like in animal.likes, we're going to print the like for each pet, for each like that the cat has. So you'll see here, and it will output each one. So if we just keep running this, you'll see it's actually slightly out of line there, but it's output food, cat treats and milk. And then it will go to the next animal. So the next animal it'll do as a new line, and this time it's going to get all of the properties from the dog class. And because it's a variant, it can do that, and it skips over the meow, and it will return the bark this time and say the dog says woof. And again, it will return all of the likes for the dog. So you see there that we actually have output with one loop without having to change anything. We've been able to use one animal interface and actually output all of the details for the cat object and all of the details for the dog object all at once. So the power of being able to dynamically type the animal, this line here, dim animal as variant, is very powerful. So dynamically changing that on each loop is great. So on one loop it can be a cat, on the next loop it can be a dog. If you had other objects such as hamsters or other pets in the pet store, then you could output absolutely any type of derived class or that was inherited from animal. So as long as it was an animal, you could go through and output and print any of the details that you wanted of these animals. So then the loop will end, and it will actually end the code. And you'll see that when the sub ends, so the very last line, instead of just ending, it will go to the class terminate option here. So you'll see here, I'll say, oh, in fact, we'll just delete everything here so we can clarify it. And just move this back up. You can drag the arrow if you need to go back a step, and we'll just do that again. So cat class instance deleted, and then it's going to terminate the dog as well, and now it will say dog class instance deleted. So both the cat and dog object you've just deleted, so those objects are gone. So, and that ends the code, and that was the last line in the code. So we actually deleted the cat, deleted the dog, and then if you imagine the image of the dog and the cat we've created, both disappearing, but we still have set up here the animal interface schematic, the cat, the class schematic, and the dog class schematic, which sit on the same level as each other. So in conclusion, we've created a cat and dog class derived from an animal interface, and we've created one cat object and one dog object from these classes. Now there's no limit to the number of dogs you could add or the number of cats you could add, so we happen to have added one of each here, but you could just keep writing code, or you could obtain data from a worksheet to populate the classes instead. In the next video we're actually going to do that. We're going to take a pet store, or I should say a pet shelter, and we're going to add the data dynamically and create these class objects including a new class object, and populate all of these objects into memory, and then do some calculations on each of these animals, objects, and then produce a report at the end of this. So this is a very powerful way to extract data from an Excel worksheet such as this and put it all into memory in a very organized way and really do absolutely any calculations you can think of on it, and also at a very quick speed as well. So we've demonstrated really solid object-oriented programming in VBA during this lesson, and you'll be able to use these objects in as many different ways as you can think. So it really is a very powerful language when you combine the object-oriented methods that VBA gives us, along with the functions and features of Excel itself. And when you combine these both together, you can really create something powerful, dynamic, and future-proofed. See you in the next video.